Hello, students. I'm sorry that I couldn't be with you today, but here we have some videos, so you're not going to miss out on learning, luckily. Your substitute today, Mrs. Gallagher, is highly capable of teaching this lesson. She's a retired math teacher and she has done this for years and years and years. But we decided that because my technology can sometimes be a little bit glitchy and the BrightLink projector can be difficult to use if a person is not used to it, that we would just play it safe and I would record these videos for you so that we didn't have any technical difficulties and that you wouldn't get behind in your learning. So we're going to cover basically sections 5.3 and 5.4 from your book, and that covers some of the basic polynomial operations as well as some types of factoring that we can use for polynomials. So our whole chapter 5 is about polynomials. Okay, so you can figure out what notes number we're on and fill that in and fill in the date, and you'll be ready to go. And at some points along the way, you're probably going to want to just pause the video so that you can write and work things out, and then resume the video so that you can see if you're doing it right. So what we have is a polynomial p of x equals 3x squared minus 7x plus 12, and q of x equals x squared minus 3. So we have two quadratic polynomials, and part A asks us to add them. This is very straightforward. All you need to do is add the like terms. So first I'm going to put 3x squared minus 7x plus 12 in for p of x, and then plus x squared minus 3 in for q of x. Add the like terms. So we have 3x squared plus x squared is 4x squared. And then we have minus 7x. There are no like terms to combine with it. And then we have 12 minus 3, which is 9. So there's our answer. Part B asks us to find p of x minus q of x. So we're subtracting this time. And it's pretty much like adding in that all you're going to do is combine the like terms. But of course you have to keep track of your signs and try to make sure that you don't make a mistake with distributing a negative or forgetting to distribute a negative. So I'm going to put minus for q of x, and then I'm going to put q of x in parentheses. So minus parentheses x squared minus 3. And then I'll distribute that negative and get rid of the parentheses. So now we have minus x squared and plus 3, and now we're ready to combine like terms. So 3x squared minus x squared is 2x squared, and minus 7x, and then we have 12 plus 3, so we have plus 15. So there is our new expression that we got by subtracting the two previous ones. And then we're also going to multiply. So we're multiplying a trinomial, p of x, it has 3 terms, by a binomial, q of x, it has 2 terms. And there's a lot to keep track of when you do this, and people have different ways they like to keep track of things, so I'll demonstrate for you a couple of different ideas. You can do it kind of with a rectangle. So if you want to use a rectangle method, you're probably going to put the longer one across the top, although it doesn't matter. So we have 3x squared minus 7x and plus 12 across the top. And then down the side, we have x squared and minus 3. And then you can draw a box. We might call it the box method, the rectangle method, whatever. I think it's probably called the box method more often. You can finish off the boxes if you want. You don't have to have little ends hanging off like I do. Okay, now you're going to multiply. And so first of all, we have 3x squared times x squared. That's 3x to the 4th. That goes in the box. Negative 7x times x squared. That's negative 7x cubed. That goes in the box. 12 times x squared is 12x squared. And moving on down to the second row, negative 3x squared times negative 3 is negative 9x squared. Negative 7x times negative 3 is positive 21x. And 12 times negative 3 is negative 36. So here we have all the terms. If you multiply 3 terms by 2 terms, you shouldn't be surprised to get 6 terms. And then we'll combine the like terms. And you might notice that with the box method, sometimes you'll have kind of a pattern. on where the terms emerge. I don't think we're seeing that this time. But anyway, we're going to combine the like terms. So we have 3x to the fourth. And then notice that we have only a single x cubed term, apparently. So that would be negative 7x cubed. And then we have a couple of x squared terms. We have this one here and this one here. So add those together, and that would be plus 3x squared. And then we just have a single x term, plus 21x. And then we have minus 36. So we didn't have a lot of terms to combine this time, but sometimes you do. So that's one of the ways you could do the problem. I'll show you what I'm more likely to do. I'm more likely just to kind of keep track and go systematically. So if I start with the first term in the first polynomial, I'm going to multiply it by each of these. Distribute is basically what I'm going to do. So that gives us, let's see, 3x squared times x squared is 3x to the fourth. And then 3x squared times negative 3 is negative 9x squared. So I'm done with the purple one, 3x squared. Then I move on to the next one, the negative 7x, and multiply it by both. Negative 7x times x squared is negative 7x cubed. And negative 7x times negative 3 is plus 21x. And now I'm done with the orange one, and I move on to the third one, which is 12, and multiply it by both. So that's 12 times x squared, 12x squared, and 12 times negative 3, so minus 36. So I'm just keeping it all in a row, but being systematic to make sure I don't miss anything. And then just like the other way, you can then combine the like terms. And you could put the terms in descending powers of x as well. That's kind of the typical way to do it. We have our two like terms here to combine. And of course, we ought to get the same answer that we got last time, hopefully. So these are two of the ways that you could multiply things out. Another way is to do kind of a vertical method of what I just did. So we could do something like 3x squared minus 7x plus 12 on the top row, and x squared minus 3 on the bottom row, and then multiply, kind of like you would multiply if you had numbers like 3,072 multiplied by 21. You might write it out like that. And then what you could do from there is take the first number, negative 3, multiply it by all three of the things on top. So negative 3 times 12, negative 3 times negative 7x, and negative 3 times 3x squared. That gives you one row. And then move on over to the second one on the bottom, x squared times 12. And you can line them up. And then x squared times negative 7x, and x squared times 3x squared. And I have vertically lined up the like terms. And again, sometimes you will have more like terms than this, but this time it just worked out only to have a couple. So you have some options for how you can multiply these together. Just choose whatever makes the most sense to you, or try the different kinds. It doesn't matter to me. Okay, let's take a look at another example. It's a little bit more general, but we're doing the same thing that we just did, which is multiply a binomial and a trinomial. We have two different examples to do, so I want you to multiply these out and combine the like terms. And we're going to use these problems to lead us into our next idea in the lesson. I think you should pause the video, give these a try, and then resume and see if we agree on the answers. Okay, so I'm going to go ahead and just multiply systematically. I'm going to take a and multiply it by all three of the terms in the second polynomial. And that gives me a cubed plus a squared b plus ab squared. And then I'm going to move on to the second one and multiply the negative b by all three terms in the trinomial. And that gives me negative a squared b negative or minus ab squared, and then minus b cubed. And then I'm going to combine the like terms. So notice that we have A plus a squared b and a minus a squared b, those cancel. And notice that we also have a plus ab squared and a minus ab squared, those cancel. So all we have left is a cubed minus b cubed. Interesting. Okay, then the one below, we'll do the same thing. Multiply a by L3, and we have a cubed minus a squared b plus ab squared, and then multiply b by L3, and we have plus a squared b minus ab squared plus b cubed, and we have a minus a squared b and a plus a squared b, those cancel. We also have a plus ab squared and a minus ab squared, and those cancel, just like in the previous problem. All we have left is a cubed plus b cubed. Okay, leading us into the next part of the lesson, you could take this problem and work it in reverse, meaning if you started with a cubed minus b cubed, now you know that it factors into a minus b times a squared plus ab plus b squared. We would call a cubed minus b cubed a difference of cubes because it's a perfect cube minus a perfect cube. So now we have a formula to factor a difference of cubes. If you see a difference of cubes, it factors into this kind of binomial multiplied by that kind of trinomial. The same thing is true down here. When you have a cubed plus b cubed, that is called a sum of cubes. And now we know, we just kind of happened upon the fact that if you were to take this backwards, a cubed plus b cubed factors into a plus b times a squared minus ab plus b squared. And we'll talk about that more in the lesson part 2 video. Thanks, guys.